A ship traveling due north with a speed of 12 km per hour relative to the water. There is a current in the water flowing at 4 km per hour in an easterly direction. 4 km per hour. Determine the velocity of the ship by scale drawing. Okay. Due north, there current water 4 easterly. Velocity of the current 4 kilometer per hour going easterly. So the ship must resist the current by going in the other direction like this, okay, to cancel out this component. It must have another component, the vector velocity, which is equal to c but in opposite direction, minus vc, still 4 km per hour. So that the result, this is the true velocity of the ship, but the sum of its two velocity, v2, and the velocity of the current, like this, v the current, okay, the sum of these two vector will be the resultant velocity, v resultant, v the ship, okay. So this is the true velocity, and one of its component is 4 km per hour going to the west, okay, and its vertical component, so vs here is like the vertical component, which has the magnitude of 12 km per hour, okay. So this is the true velocity of the ship, and that velocity can be easily calculated by Pythagorean theorem, the v of the current square and add it with the velocity going to the north square. That is the square root of 4 square and 12 square, and we will have square root of 4 square and 12 square. We will round to 2 decimal places here. 13 km per hour rounded. Ready. 2 significant figure, checking answer here. 12.6. Yeah, they didn't round the accurate value. 12.6. Write that again. 12.6. Do we need to determine the velocity? Okay, when the question is velocity, determine velocity, not only speed, we need to determine the direction also. So you can determine that direction by saying the bearing, this angle, or you can say like how many degree west of north, okay, meaning you need to calculate this angle. Easy to calculate this angle, right? Because we know the opposite side here is 4 and this adjacent side is 12. So we can calculate this angle, right? 4 here and 12 here is the adjacent side. So this angle theta, opposite over adjacent is the tan, tan of theta is 4 over 12. And therefore the angle theta is the inverse tan of 4 over 12, 1/3, Okay, I need to change this setting into degree, not radian. Yeah, to degree again.
It's 18 point.
18 degree, 18 point something.
Yeah, 4.3.
Yeah, 18.3 degree. So the conclusion, the velocity is 12.6 west and 18.3 degree west of north. Okay, velocity is 12.6 kilometer per hour and 18.3 degree west of north. That is how you answer a question about a vector with the direction, indicating the angle compared to a direction such as the north direction, okay. And in the problem, like the previous problem about the airplane, they say 30 degree north of west. A fielder in a cricket match throws a ball to the wicket keeper. What does it mean by cricket? Similar to baseball, but not baseball, right? So the wicket keeper. At one moment of time, the ball has a horizontal velocity of 16 meters per second and velocity of vertical upward direction 8.9 meters per second. Determine for the ball the resultant speed, horizontal velocity, and the velocity of the vertical upward direction. So basically, the question gives the two components, and you simply just need to add those two components. One component is horizontal, which is 16 vx, 16 meter per second, and the vertical component is 8.9 vy, 8.9 meter per second. So adding them using Pythagorean theorem, very easy, Just please tell me your calculation, the final result. Yeah, rectangle, this is v total, root of 16 square plus 8.9 square. Rounded to two significant figures, 18. Yeah, it makes sense. Must be greater than 16. 18 meter per second. That's it. Question A1. 2. The direction in which it is traveling relative to the horizontal. Please determine that angle. Easy. use tan or sine or cosine, anything. Which one do you choose? Sine or cosine or tan? Tan, huh? Tan theta is opposite, which is 8.9. Jason is 16. So the angle is how many degrees? 29. During the flight of the ball to the wicket keeper, the horizontal velocity remains unchanged, meaning 16 doesn't change. The speed of the ball at the moment when the wicket keeper catches it is 19 meters per second. Wait, 19 greater than 18? The speed of the ball at the moment when the wicket keeper catches. Horizontal velocity remains unchanged. The speed of the ball at the moment. Okay, the ball just as it caught is vertical speed, but the vertical component is downward. Vy equal to 8.9 meters per second. It should be downward like this so that the weight, the gravity, will accelerate it, making it bigger, greater than 9.8. And therefore, the total velocity will be 19 when reaching the hand of the keeper, 19 here. Okay, calculate its vertical speed, easy. So now you have the new velocity is 19, which is greater than 18, okay, meter per second. But the horizontal component doesn't change. It is still 16 meters per second. So you just need to calculate the new vertical component here, Vy new. It must be greater than 9.8, okay? And you can calculate that easily by Pythagorean theorem again, okay? So that this new component is square root of 19 square, huh? Minus 16 square, right? Which is
10.
Okay, 10. Obviously, greater than 9.8, huh? 29 degrees, 10 meters per second, see? Yeah, that's correct solution. Question 2. The angle that the path of the ball makes with the angle the path makes with the horizontal, meaning they're asking for this new angle. What letter should I call this angle? Theta again. I think I can use the letter phi here or alpha, huh? Now, they're asking for the new angle here. And again, you can calculate that angle easily, right? Tan alpha is 10 over adjacent 16, huh? So alpha is how many degrees? 32 degrees. Okay, the answer 33. The last one, question C. Suggest with a reason whether the ball at the moment it is caught, is it rising or falling? I already explained that, right? It must be falling because the speed here is greater, 19 is greater than 18, meaning the velocity nu is greater than the old velocity 9.8. Because of the acceleration to gravity, the weight, and therefore it is falling, not rising, because there is no other forces increasing the speed, accelerating the speed of the ball, and therefore the only reason why the velocity of the ball is 19 greater than 18 is because of gravity. Okay, so that's why I changed the drawing from going up to going down. The vertical component of the velocity didn't provide the answer here. Okay, that is it.